Today we are going to study redox reaction. Okay, the chemical reactions in which electron transfer takes place from one substance to another are known as redox reactions, or the chemical reactions which involves oxidation and reduction simultaneously are known as redox reaction. Here you can see CuSO4 plus Zn, ZnSO4 plus Cu. What happens is this. You can see CuSO4 plus zinc 2, ZnSO4 plus Cu. So what happens here, it is in 0 state, but here it is in plus 2 state. So it has lost electrons, and what, it has plus 2 and it has gone into 0. So it has gained electrons. Okay. Now oxidation number. Real or hypothetical charge on an atom in a molecule or ion is known as oxidation number. Here you can see coordinate bond, and here like 0 and 0, it's here between this one and this one. Calculation of oxidation number. Free state, we let it to be 0. Na 0, Ag 0, zinc 0 and Fe 0. In metallic state they have oxidation number of 0 state, or in free state they are having oxidation number 0. H2 in molecular form they also contains 0 oxidation number, H2, O2 and N2. In allotropic form, carbons having 2 allotropic form in the form of graphite and diamond, so it is having 0 oxidation number in graphite, and in diamond also it is having 0 oxidation number. Now alloys, NaHg, Au and Cn, oxidation number 0. Okay. Now group 1 like Na group 1. लीना ना कर रब से फरियाद. So these all are having oxidation number of plus 1. Okay. And group 2 is having oxidation number of plus 2. Like beta mange car scooter baap raji. Okay. And these all are having oxidation number of plus 2. Hydrogen can be in oxidation of number having oxidation number of plus 1 or minus 1. Generally with metal hydride like NaH you can see. In NaH what happens is this, NaH minus 1 plus 1, and MgH2 generally not happens, but what we can see is like this, LiH. It is having plus 1, so hydrogen is having minus 1. And HCl, oxygen generally in minus 2, and now in some state it can be in plus 2 with most electronegative elements like fluorine. Oxygen fluoride, it is having plus 2. You can see how O, F and F. This contains minus 1, this contains minus 1. So this contains plus 2 to make it overall 0. O2F2. O2F2. So F contains minus 2, so it's contains plus 2. So plus 2 by 2 equal to plus 1. Now peroxide, O2 2 minus. Oxidation number of oxygen in it is minus 1, like peroxide, hydrogen peroxide. In superoxide it contains oxidation number of half, KO2 NaO2. Ozonide O3 minus, KO3 minus, 1 by 3rd. Okay, I can explain it a little bit like this. O2 2 minus, so 2x equal to minus 2, so x equal to minus 2 by 2, minus 1. Okay, like this. In case of peroxide it contains minus 1, and in case of superoxide it contains O2 minus, so 2x equal to minus 1, so x equal to 1 by 2, superoxide minus half. Okay. And in case of ozonide, O3 minus, like KO3, 3x equal to minus 1, so x equal to minus 1 by 3. Ozonide minus 1 by 3. Okay. Now in case of halogen you can see F always in minus 1 state, Cl, Br and I normally minus 1, but they can go to up to plus 7. Okay. Now ligands. In chemical coordination you have read a lot about ligands. They are Lewis bases. So now K4FeCN6 whole 6, neutral, H2O, NH3, CO, C2H4, oxidation number of 0. Positively NO plus, nitrosyl, negative, cyanide. Now hydrogenium ion plus, and N2H5. Now 1 minute, I can make oxidation number of K4FeCN6. So this one is, so here minus 4 will come. Let it we have to find. So x plus 6 into minus 1 equal to minus 4. So x equal to minus 4 plus 6 equal to plus 2. So Fe equal to plus 2. Okay. Down, 1 minute. Down the group, oxidation number decreases, inert pair effect, like you can see in this P block. And primary is oxidation number, primary valency is oxidation number, and secondary valency is coordination number. Now, in case of polyatomic molecules or ions like H2SO4 and NO3 minus, what we can do is like this. If we have to find for S and for N, so let's see how. H2SO4, so for hydrogen we is going to 2 into 1 plus x plus 4 into minus 2 equal to 0. So 2 plus x minus 8 equal to 0, x equal to plus 6. S gonna be having plus 6 oxidation number, okay? And in case of NO3 minus, let it be x plus 3 into minus 2 equal to minus 1, x equal to minus 1 plus 6 equal to plus 5. Okay. Now, we have to find oxidation number of underlined atoms in the following compounds. So we're going to find oxidation number for these, okay? KMNO4. So K is from first group, so it is having oxidation number of plus 1 plus Mn plus 4 into minus 2 equal to 0. So 1 plus x minus 8 equal to 0, x equal to plus 7. Mn is having plus 7 oxidation number. Now, K2Cr2O7. 2 plus 2x plus 7 into minus 2 equal to 0. So 2 plus 2x minus 14 equal to 0. 2x equal to 12, x equal to plus 6. In K2Cr2O7, Cr is having plus 6 oxidation number, okay? Now, H2SO3. 2 plus x plus 3 into minus 2 equal to 0. 2 plus x minus 6 equal to 0, x equal to plus 4. HClO4. 1 plus x plus 4 into minus 2 equal to 0. 1 plus x minus 8 equal to 0, so x equal to plus 7. This we have to find oxidation number of Cl. So there are two Cls, so they are having different oxidation number. Like you can see, it is having plus 1 also and minus 1 also. Okay, so average atomic number, like sum of two equal to 0. How? Let's see. CaOCl2 is having a structure like CaOCl and Cl. Okay, this is from group 2, so it is having plus 2 oxidation number. Now what gonna happen is it is distributed equally, so overall it is having minus 1. It is having minus 1, so we have fine. So OCl is having minus 1 oxidation number. So oxygen minus 2 plus x we have to find equal to minus 1. So x equal to minus 1 plus 2 equal to plus 1. Okay. So 1 Cl is having plus 1 and 1 Cl is having minus 1. Average equal to 0 in CaOCl2. Now, NH4 plus and NO3 minus. So you have to distribute like this. In case of magnetite Fe3O4, average atomic number is plus 8 by 3, like FeO plus 2 and Fe2O3 plus 3. Okay. Now, Br3O8, it is repeated in NEET 2019. So I wanna draw this picture of this Br3. Br3O8. Okay. Firstly, we will write Br, and Br. Okay. So minus 2, minus 2, minus 2. So what? Plus 6. Minus 2 and minus 2. Plus 4. Minus 2, minus 2, minus 2, plus 6. Okay. 1 minute. Sorry. This one gonna be plus 7 because this one also shares and this one also shares, so plus 7. And in NiCO4, Ni is having oxidation number of 0. In this you can see light. I will solve it for you. So this whole having plus 2. So x whole is having 0. X plus 0 minus 1 equal to plus 2. So x equal to plus 3. This is having minus 1. K3 FeCN6. So this one gonna be minus 3. So we have to find for this. X plus 6 into minus 1 equal to minus 3. X equal to minus 3 plus 6. X equal to plus 3. Okay. Potassium ferricyanide. Oxidation number of S in Carose acid. What is Carose acid? It is having formula H2SO5. So Carose acid H2SO5. How? Let's draw. S double bond O, OH, O, OH. So minus 2, minus 1. And this is peroxide linkage. And one more. 1, 2, 3, 4 and one more. So minus 2 and minus 1. दो बचा पास and अच्छा. Glucose is having oxidation number of carbon 0. In glucose, carbon is having oxidation number 0. Now application of oxidation number. First, determination of acidic and basic strength. HClO4, HClO3, HClO2, HClO. Acidic strength is directly proportional to oxidation number. If high oxidation number, then it is more acidic. Which one is more acidic? So you have to see which one is having bigger oxidation number. That one which is having bigger oxidation number will be more acidic. Okay, from these both, which one is having more acidic strength or better acidic strength? So I gonna see +6 oxidation number. So SO3 is having more oxidation strength or acidic strength. And basic strength is inversely proportional to oxidation number. Second application of oxidation number is determination of oxidizing and reducing nature. Oxidizing agent, maximum oxidation number, only acts as oxidizing agent. In KMnO4 you can see Mn is in highest oxidation number of +7, so it can only be act as oxidizing agent. Oxidizing agent are reduced, so it will go into lower oxidation states now. K2Cr2O7 is in having +6 oxidation state, so it will go in lower oxidation states. H2SO4 S is having in +6 oxidation state, so it will go in lower oxidation states. Oxidizing agent are reduced. You have to learn this sentence. HClO4 is having in +7 oxidation state. Now Cl will go in lower oxidation states. HNO3 +5. Now it will go in lower oxidation states. Minimum oxidation states act as a reducing agent. Like reducing agents are oxidized. You have to learn this. Like in NH3, N is in -3, so it will go in higher oxidation states. H2SS is in -2 state, so it will go in higher oxidation state like this. You have to learn this. Whenever S is in -2 oxidation state, it acts as reducing agent and it gets oxidized into S having 0 oxidation number. Okay, this is very important. Now, sometimes we can see like it is in intermediate oxidation number. HNO2, in HNO2, get into from +3, it will go into +5 or either +5 or -3. And hydrogen peroxide acts as both oxidizing agent and reducing agent. It will form H2O, in which it is in -2, and in O2 it is having 0 oxidation number. Now equivalent weight. The weight of substance which is involved in oxidation or removal of 1 mole electron is called as equivalent weight of oxidizing agent or reducing agent. Oxidizing agent gain electron and they get reduced. Reducing agent get oxidized by losing electrons. A reducing agent in lower oxidation number and oxidizing agent is having higher oxidation number. And equivalent weight equal to molecular weight by number of electron gain or lost per mole. So what per mole? You have to think over it. In acidic medium, KMnO4 plus Fe2 plus H plus Mn2 plus Fe3 plus. So what you are seeing from +7, it is going into +2. So how many electrons are gained? There are 5 electrons gained in this reaction. 1 mole of KMnO4 accepts 5 mole of electrons. So equivalent weight of KMnO4 equal to molecular weight of KMnO4 by the number of electrons gained. Number of electrons gained. So 5. Okay. Equivalent weight of Fe. Fe is going from +2 to +3 state, so loss of 1 electron. So molecular weight by 1 is the equivalent weight of Fe2 plus. Now, in neutral or weak alkaline medium, KMnO4 is changing into MnO2 from +7. It is going into +4, so it is gaining 3 mole of electrons for each KMnO4. So equivalent weight of KMnO4 equal to M by 3. Okay, in a strong alkaline medium, KMnO4 goes into MnO4 2 minus, or you can say like this, K2MnO4. So from +7 it is going into +6. So equivalent weight of KMnO4 equal to M by 1. For KMnO4 I have a trick which my teacher in our class taught me, like a KMnO4. So you can learn it by BNA. B for basic medium, neutral and acidic medium. So BNA 1, 3 and 5. Gain or loss of electron. Okay. In this neutral or weak alkaline medium, you have seen that it has gained 3 mole of electron. So in neutral medium 3, and in strong alkaline medium it has gained 1 electron, like 1. So you can see I have written here 1. And in acidic medium it has gained 5 mole of electrons. So this is gonna be 5. So you can learn this trick. In acidic medium, K2Cr2O7 goes from +6 to +3 for 6 electron accept. So for per mole, you have to think. So per atom, 3 electrons are gained. So 2 atoms of Cr in 1 mole of K2Cr2O7, 6 electrons are involved. In alkaline medium, it is from orange, it goes yellow. Now, determine the equivalent weight of reactions in the following conversions. So from -1, it's going into +5. So it has gained 6 electrons. It has lost 6 electrons actually. I2 to 2I minus. You can see +3 to +4. So we have to think per atom. So it's coming 2 because here 2 Here disproportionations occurs. From 0 it's going into -1 and as well as +5. So you have to add and then write. I will calculate this for you. Only oxidation is occurring. So oxidation, less electron 1 and loss of electron 2. So total loss of electron is 3. So there is loss of electron. So we can say it is oxidation. So only oxidation is occurring. So equivalent weight equal to molecular weight upon 3 electrons. Now in compounds what we see is total positive charge equal to total negative charge. So for example we can calculate like A equal to -1, B equal to +8 and C equal to -2. So A2, B3, 6. So anyone overall should be 0. Okay. So now how many formulas can be there? Like this. You can put 2 into -1 plus 8 plus 3 into -2. So it's coming 0. So it is correct formula. And if it's A4, BC2, so 4 into -1 plus 8 plus 2 into -2. If it is coming 0, then it is also a correct formula. And one more formula is there, A6B3. You can make your own formulas. 6 into -1 plus 8 minus 2 equal to 0. So it is also correct formula. So now types of redox reactions. Intermolecular redox reaction between two molecules, SnCl2 plus FeCl3, SnCl4, FeCl2. So from +2 it's going in +4, from +3 it's going into +2. Intramolecular redox reactions within a molecule, like KClO3 -6 plus from +5 it's going into -1 and to 0. So you can removed or gained electrons 6. 6 electrons are gained because from +5 it's going into -1, so there are gain of 6 electrons. And you can see in oxidation -6 it's 6 electron removal. Okay, Cl minus and ClO3. This proportionation occurs, same reactions which I teach to you earlier. Now come proportionation. From -1 it's going to +0, only 0, and from +5 it's going into 0. So equivalent weight of chloride ion is m/1, equivalent weight of ClO3 minus is m/5. Two different molecules going into a single product. Balancing of redox reaction and electron method. So what we have to do is half reactions, balancing of atoms other than O and H. O add H2O, H add H plus. In alkaline medium, equal number of OH are added on both sides after adding H on deficient sides. Charge balance, add electron, add half reactions, so it's completed. And in oxidation number method, which I like the most. Half reactions, balancing of atoms having charge in oxidation number. Total increase in oxidation number should equalize total decrease in oxidation number. Add these half reactions, balancing of charge. Add H plus OH minus, basic balancing of ONH. Okay. Like I can teach you a reaction. Law of Equivalence. Simplest whole number ratio between reactants and products, a balanced chemical reaction 1, 3, 2, 1, 3 and 2. Equivalents of reactants are equal, equivalents of products are equal. Equivalent equal to weight by equivalent weight equal to normality into volume, m into n factor into v, mole equal to m into n factor, molarity into n factor. Okay, mole equal to m into v. In case of redox reaction, equivalent weight of oxidizing agent equal to equivalent weight of reducing agent. Moles into n factor, oxidizing agent, moles into n factor, reducing agent, m1 v1 f1 n1 f1 equal to m2 v2 n f2, n1 v1 equal to n2 v2.